All right, remember from last night that relations are simply ordered pairs where my x corresponds to my y, or my input corresponds to my output. And a function is a relationship where x does not have more than one y. Each x has only one y value, or that each input has one output. I can think of x as an input variable and y as my output. I can also use the term independent variable because I can choose whatever x value I'm going to put into a function, and that's going to determine what my y value is. So my y is my dependent variable because whatever y equals depends on x. All right, so let's look at putting the data in this table into ordered pairs. So I'm going to take this first data set, -3, -7. Remember that your x value comes first. So if I write it as an ordered pair, it's -3, -7. Let's do that for the others. Hopefully you get this. All right, and remember that on my x-axis is where I graph my independent variable, and my dependent axis is my y. Y has the tail, so y is the vertical one. And let's look at plotting these points. For -3, -7, I'm going to start at the origin. I'm going to go left 3 spaces because it's negative. And then to graph the -7, I'm going to go from my x value down 1, 2, 3, 4, 5, 6, 7. And I should end up right here with my point. All right, so let's have you graph the others on your own paper, please, and let's check your work. All right, you should have plotted your points so they look something like this. And notice that I can draw a line straight through these, and that will give me a graph of my information. So again, just to review, I took a function because each x only had one y. This was a function, and I plotted this function on a graph using my first set of points as my independent variable, or my x, and my second as my y. I wrote them as ordered pairs, and then I graphed them, and I drew a line to connect the points. So when we look at graphing a function, we're going to look at making a table and turning it into coordinates, and then putting it on our coordinate plane. Notice that y equals 1/2 x plus 3 is technically a function, and I can rewrite this even as the function of x, given that x is my variable. Because y is my dependent variable, it depends on my x values. So it is a function of x, a function of the dependent variable. So the function of x equals 1/2 x plus 3. This is the exact same thing as y equals 1/2 x plus 3. You might even see it written this way sometimes. So to model what this looks like on a graph, I want to find some values of x, and then look at what those would produce with y. So for these, let's look at doing -4, 2, and 0, -2, and 0. Now whatever I take on the negative side, I want to go ahead and add those opposites so I can see what it looks like with positive values of x. I like 2s and 5s in general because they're easy to work with. Now if I plug x in, all right, let's see what happens when I plug these x values in place of x. So if I take the first one, I have -4, I'm going to plug -4 in place of x, and you're going to notice that -4 times 1/2 is -2, plus 3 equals a positive 1. This becomes my y value. What this is saying is that the function of x when x is -4 equals 1. And the function of is the same thing as saying y equals 1. Do the same thing for the next point. My next x value is -2. Plug it in place of x. The function of -2 is 1/2 times -2, or -1 plus 3, which is the same thing as 2. Alright, do the same thing for 0, 2, and 4, and let's check your work when you're done. Alright, hopefully these were the answers you got for your y values and how you completed your chart. If you had questions on zeros, see how I've solved it down here. Now, when we want to plot these points, we want to think of these as coordinate pairs. So remember that when I write coordinate pair, my x comes first, then my y. So here, my x value is -4, come on. Next coordinate is -2, 2. Next one is 0, 3. After that, it's 2, 4. Then 4, 5. All right, now I'm going to look at graphing these. Remember that my x is my horizontal plane, and that my y is my vertical plane. And the way I remember that is because y has a tail that goes up and down. Right, so if I'm going to graph these, make sure you have a graph out. If you have graphing paper, you've written out an area that looks just like this. And let's look at graphing these. So if I'm going to graph point 1, I'm going to go -4 on my x. So that's to the left, 1, 2, 3, 4. And then I'm going to go up 1. Why 1? Well, because this is technically +1, and positive goes up. The next point I'm going to plot, I'm going to start with my x, which is -2. Start at the origin, okay. Let's graph the next pair. The next one is -2, 2. So remember, -2 is my x. So I'm going to start at my origin. Always start at your origin. And you're going -2. So that's 2 to the left. Good, that's right here. And then I'm not done. I need to plot my y. From here I need to go up 2, y up, because this is positive. Up 2 is going to put me right here. I'm going to plot my next point, and I'm going to start at 0. Oh, look, my x doesn't move. My x is 0. So I get to move straight to my y value, which is 3, and it's positive, so I'm going to go up 3. 1, 2, 3. All right, plot your next 2 points, and let's see how you do with this. All right, hopefully you plotted these points just like I did. If you'll notice that these are at the place where lines intersect. They are not in the middle of a square, nor are they in the middle of a line. They are where multiple lines come in and intersect. All right. Next thing we're going to do when we're modeling a function is to draw a line. We're going to connect our dots. All right, so I'm going to connect these. It's really helpful if you have a piece of paper. You can line up against your pencil so you have a really straight line. Notice that your line is going to extend infinitely. I could keep going, and it should go just like this. So you want to make sure you have arrows on the end of your line. This is not a line segment. This is an infinite line without end. And you have successfully modeled your first function. All right, next I'd like you to do one on your own. The one I would like you to do on your own is to model the function f of x equals 3x plus 4. Remember, this is the same thing as saying y equals 3x plus 4. I'd like you to model this with a table, just like I have. Then I'd like you can skip the area where you have the coordinates if you feel confident enough. But then the last thing you're going to do is you're going to plot your points, and you're going to graph a line. Make sure you have all of this work. This can be example 1 on your paper. I will check this in class tomorrow.